our classes. In today's video lecture, we will discuss beta distribution of second kind. In the previous video lecture, we have already discussed beta distribution of first kind and we have obtained mean and variance of beta distribution of first kind. Now, in this video lecture, we will obtain mean, variance and harmonic mean of beta distribution of second kind. But first of all, let's see how we define beta distribution of second kind. Here our f of x is defined as 1 upon beta mn x to the power m minus 1 plus x to the power m plus n. Here m and n are the parameters greater than 0 and x lies between 0 to infinity, 0 otherwise. Now here we want to find out mean. So first of all we will find out rth moment about origin, that is mu r dash. And then what we will do, we will put value of r equals to 1. We will get expectation of x, that is mu 1 dash. And then we will put r equals to 2 to get expectation of x square. And with these two values we can easily find out variance of x. So let's start with it. Mu r dash, how we define it? Integration. Here what is the range of x? 0 to infinity, x to the power r into fx dx. Now here let's put f of x. So what we will get? Integration 0 to infinity x to the power r 1 upon beta mn x to the power m minus 1 plus x to the power m plus n dx. Right? Now here 1 upon beta mn is a constant. We can take it outside the integration. We get 1 upon beta mn integration 0 to infinity. Now here we have x to the power r, x to the power m minus 1. So we can write down these two terms together using rule of indices, which says a to the power x into a to the power y equals to a to the power x plus y. Right? So using that we are writing here x to the power m plus r minus 1 upon 1 plus x to the power m plus n dx. Okay. Now in the numerator we have m plus r. Now let's compare these two terms. So here x to the power m minus 1 plus x to the power m plus n. So if we will compare, instead of m, now what we have? M plus r. So in the denominator also we have to adjust the term plus r. And of course, if we are adding plus r, we have to subtract r, right? So let's rearrange it. So what we will get? 1 upon beta mn integration 0 to infinity x to the power m plus r minus 1 upon 1 plus x to the power m plus r plus n minus r dx, right? So now we are getting the same beta distribution of second kind. Only difference is instead of m we have m plus r and instead of n we have n minus r. That's why we can write down here, it is nothing but 1 upon beta mn and here beta m plus r n minus r. Now we can solve it further. How to solve it? So we know that beta mn equals to gamma m into gamma n upon gamma m plus n, and gamma n is nothing but n minus 1 factorial. So using these two results we can easily solve it. So let's solve it. So we will get 1 upon gamma m gamma n upon gamma m plus n. So that we can take in the numerator. So we will get here m plus n. And let's solve this term. So it will be gamma m plus r gamma n minus r upon gamma m plus n plus r minus r. Okay, plus r minus r will get cancelled. So we will just get here gamma m plus n. And this gamma m plus n will get cancelled. So we can write down this as m plus r gamma n minus r upon gamma m gamma n, and this is our rth moment about origin. Okay, we can solve it one step ahead. So what we will get, m plus r minus 1 factorial n minus r minus 1 factorial upon m minus 1 factorial n minus 1 factorial. So now this is the simplest. We just have to put value of r equals to 1 and 2 to get expectation of x and expectation of x square. So let's do that. First let's find out expectation of x, that is mu 1 dash. Okay, so what we have to do, instead of r we have to put now value 1. So here plus 1 minus 1 will be 0. So we will get m factorial n. Minus 1 will be minus 2 factorial divided by m minus 1 n factorial n minus 1 factorial. Okay, so let's solve this further. We will get m into m minus 1 factorial. Let's keep n minus 2 factorial as it is. In the denominator m minus 1 factorial, and here let's expand. So n minus 1 factorial, so we will get n minus 1 into n minus 2 factorial. This n minus 2 factorial, m minus 1 factorial will get cancelled. So we will get expectation of x equals to m upon n minus 1. Okay, now we want to find out expectation of x square. So let's put value of r equals to 2 in this equation. Now expectation of x square equals to, what we have to do, we have to put value of r equals to 2. So m plus 2 minus 1 will be plus 1. So we will get m plus 1 factorial. Here n minus 2 minus 1 will be n minus 3 factorial divided by m minus 1 factorial n minus 1 factorial. Let's expand this m plus 1 factorial. We will get m plus 1 into m minus 1 factorial. Let's keep n minus 3 factorial as it is, and in the denominator m minus 1 factorial. Now let's expand n minus 1 factorial. It is n minus 1, n minus 2, n minus 3 factorial. This n minus 3 factorial will get cancelled and m minus 1 factorial will get cancelled. So in the numerator we will get m into m plus 1 upon n minus 1 into n minus 2. This is our expectation of x square. Now we want to find out variance of x. What is the formula? It is expectation of x square minus expected value of x whole square. Let's put these two values. We will get here m into m plus 1 upon n minus 1 n minus 2 minus expectation of x is what? M upon n minus 1. We have to take it square. So it is m square upon n minus 1 square. Okay. Now here we can see m upon n minus 1 is common. So we can take it outside. So we will get m upon n minus 1. Now in bracket what will be there? M plus 1 upon n minus 2 minus m upon n minus 1. Right? Now let's take LCM. So what we will get? Variance of x equals to m upon n minus 1 into m plus 1 into n minus 1 divided by n minus 1, n minus 2, and of course here also we have to take LCM, minus m times n minus 2. Right? Now let's solve these two brackets. So what we will get? M upon n minus 1. Here it is mn minus m plus n minus 1 minus mn plus 2m divided by n minus 1 n minus 2. Right? Now here plus mn minus mn will get cancelled. Plus 2m minus m will be plus m. So we will get m upon n minus 1, and here it is m plus n minus 1 divided by n minus 1, n minus 2. This is our variance of x. We can write down one step more, m into m plus n minus 1 upon n minus 1 square into n minus 2, and this is also in some books it is given like that, right? This is the mean and variance of beta distribution of second kind. Now we will obtain harmonic mean of beta distribution of second kind. Here harmonic mean denoted as h and is given as 1 upon h equals to expectation of 1 by x, and expectation of 1 by x is integration range is 0 to infinity 1 upon x fx dx. Okay, now we will put f of x here. So what we will get, integration 0 to infinity 1 upon x 1 upon beta mn x to the power m minus 1 1 plus x to the power m plus n dx, right? Here 1 upon beta mn is constant. We can take it outside the integration. So we will get 1 upon beta mn integration 0 to infinity. Now here what we have, x to the power m minus 1, and here it is 1 upon x. So if we will take x in the numerator, it will be x inverse. So we will get x to the power m minus 1 upon 1 plus x to the power m plus n dx. Okay. Now here again instead of m we are getting m minus 1. So of course in the denominator also we have to adjust that term. So here minus 1 plus 1. Okay. So let's write down this again. So what we will get, 1 upon h equals to 1 upon beta mn into integration 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m minus 1. So of course with n we will get n plus 1 dx. Okay. So now we are getting here beta integral with parameters m minus 1 and n plus 1. That's why we can write down here 1 upon beta mn as it is, and it will be beta m minus 1 n plus 1, right? Now we can solve this term further. How to do that? We know that beta mn equals to gamma m into gamma n upon gamma m plus n, and gamma n is nothing but n minus 1 factorial, right? So let's use this two result to solve it further. So we will get gamma m plus n upon gamma m into gamma n, and here gamma m minus 1 gamma n plus 1 upon gamma m minus 1 plus n plus 1 minus 1 will get cancelled, and here we will just get gamma m plus n. This will get also cancelled. So we will get here gamma m minus 1 gamma n plus 1 upon gamma m into gamma n. We can solve it further, right? Gamma n is what? N minus 1 factorial. So here m minus 1 will be m minus 2 factorial. Here n plus 1 minus 1 will be n factorial divided by m minus 1 factorial and n minus 1 factorial, right? So now let's solve it further. So what we will get, m minus 2 factorial, let's keep it as it is, n into n minus 1 factorial, and here let's expand m minus 1 factorial. So we will get m minus 1 into m minus 2 factorial into n minus 1 factorial. This n minus 1 factorial will get cancelled, m minus 2 factorial will get cancelled, and we will get n upon m minus 1 is the value of 1 upon h. But now what we want h, so we have to take its reciprocal. So we will get value of h equals to m minus 1 upon n, and this is the harmonic mean for beta distribution of second kind. For more videos, like, share and subscribe the channel.